Hello, today we are doing ICSE Mathematics sample paper, okay, section B. Now, there are 7 questions in the sample section B. So, we are asked to do any 4. Okay, we have already done 4 questions. Okay, uh, question number 4, 5, 6, and 7 we have already done from the section B. Now there are 3 remaining questions, question number 8, 9, and 10. Today we will be doing only question number 8 and 9. Next class I will be doing the question number 10. Okay, now what is the question number 8 saying? The, eh, the first part of question number 8. In a TV show, a contestant opts for video call a friend lifeline to get an answer from 3 of his friends named Amar, Akbar, and Anthony. The question which he asked from one of his friends has 4 options. Find the probability that Akbar is chosen for the call. B. Akbar couldn't give the correct answer. So, here we will be doing this sum. Okay, now I am starting. So, number A I am doing first. Okay, now you please pay attention. Okay, so a person is using a lifeline for giving an answer. So he may call any 3 of his friends, Amar, Akbar, and Anthony. So in the A part, it is asking, what is the probability that he chooses Akbar for the call? Okay, now A part I am doing. So number of friends. So the number of friends are how many? So the number of friends are 3, from which he can choose only one. So number of friends. So the number of friends he can choose. He can choose is only one. Okay. So let S be. Let S be the total sample space. So let S be the total sample space. That is the number of all possible outcomes. Okay. NS is denotes the number of all possible outcomes. So he from the 3 friends, he can choose any one of the 3. So NS is 3. So let E be the event of choosing Akbar. We are asked, what is the probability that he chooses Akbar? So we are denoting that event by E. Okay. Now, in how many ways he can choose the Akbar? Okay, only by one way. Okay, so what is the probability of the event? So the probability of the event, that is the probability of choosing Akbar for the lifeline. Okay, so he is the probability will be Ne upon Ns, that is number of or a number of okay number of choices probable to the event divided by all possible choices. So it is 1 upon 3. That is the probability of choosing Akbar. Now the B part. Akbar couldn't give the correct answer. What is the probability? Okay, now the B part. So number of choices for the answer. Number of choices for the answer. So in the question we are told that there are four options for the answer. So the number of choices for giving the answer is four. Okay, now out of these four, there is only one correct answer. So uh, he can choose only one answer. So let S be the total sample space. So let S be the total sample space. That is the number of ways of making any one choice. So it is out of the four given choices, he can choose any one out of those four. So NS is 4. That is all possible outcomes. Let us first assume, let us take the event of making a correct answer. Let E be the event. Let E be the event of choosing the correct answer. Of choosing the correct answer. So we are denoting that event of choosing the correct answer by E. Okay. So how many ways a correct answer can be chosen? So out of the four given choices, there is only one correct answer. So the number of ways of choosing a correct answer will be one. So the probability of making a correct answer. So it is NE divided by NS. That is the number of choices favorable to the event. That is for giving the correct answer. Divided by all possible outcomes. That is all possible ways of choosing the one answer. It is 1 upon 4. But in the question, it is asked, what is the chance of Akbar not giving the correct answer, which is denoted by PE dash. So the probability Akbar not giving a correct answer. So Akbar not giving the correct answer, not giving the correct answer. Okay, so it is denoted like this, PE dash. So E complement, which we call not E. So it is formula is 1 minus PE. That is the 1 minus total probability is always 1. From 1, you will subtract the probability of giving a correct answer. So 1 minus 1 upon 4. So which comes to 3 upon 4. So this is the probability of Akbar not giving the correct answer. Now we are moving to the number 2 question. Okay. So what is the sum saying in the second? Here it is saying there are three numbers x, y, and z which are in continued proportion. So we have to prove x divided by y squared times z squared plus y divided by z squared times x squared plus z divided by x squared times y squared. Value is equal to 1 upon x cube plus 1 upon y cube plus 1 upon z cube. So in the question, we are told x, y, z are in continued proportion. So because x, y, and z are in continued proportion. Okay. So what is the meaning of continued proportion? Okay. So we are told that these three numbers x, y, and z are in continued proportion. So it means x divided by y is same as y divided by z is equal to k. Say so the when it is told continued proportion, it means the first term divided by the second term value is same as the second term divided by the third term, which we have taken as k. Okay, now we will express all the three terms x, y, and z in any one. Okay, So here you pay attention. The x value will be k times y, and the y value will be k times z. Okay, so here in place of y, I am putting kz. Okay, and z will be taken as z. So in place of y, I am putting kz. So x value will be k multiplied with the value of y, which is kz. So this comes to k squared z. So we have expressed x, y, and z in terms of z. Now start from the left hand side. So LHS. So what is given in the left hand side? X divided by y squared times z squared plus y divided by z squared times x squared plus z divided by x squared times y squared. Now you put x, okay, express all the in one, that is in the form of z. I am expressing x, y, and z. So x value in the terms of z is what? It is k squared z whole divided by y squared. Y squared value is in terms of z, kz. So that whole squared multiplied with z squared. Now again write y on the top. Y value in terms of z is kz divided by z squared times x squared. So x value in terms of z is ky whole squared plus z you write as z x squared. X in the terms of z is k squared times z whole squared times y squared. So y squared in the form of z is yz whole squared. Now you please simplify this. So this becomes k squared z whole divided by k squared z squared times z plus kz whole divided by k squared times k squared y squared. Oh, sorry, I have made a mistake. You have to put here x in terms of z. So all you express in terms of z. So here in terms of x squared, you will have to write the value in the terms of z. Okay. Now you have to write here. I have written xy. Okay. You have to express it in terms of z. Okay. So I am expressing in terms of z. Okay. Now x value in terms of z is k squared z. So right here, k squared z, okay, in terms of x, okay. So that will become what? K squared whole squared, okay. Now what will be the value of it? So you write here. So that becomes, okay, k squared, okay, kz divided by z squared, and k squared whole squared is k to the power of 4. Powers will be multiplied. We know that a to the power of n whole to the power of n is a to the power of mn. Powers are multiplied. So 2 times 2 is 4 into z squared plus z, okay, divided by. So here, okay, and here, okay, this is kz, sorry. Y value is kz, sorry. So here you have to write kz, sorry. Okay, y value is kz. So this become k to the power of 4 z squared times k squared z squared. Okay, so that is the formula. Okay, now you please simplify it. So k and z cuts out from the top and down. K squared and k squared cuts out. Here we are dividing z, okay, with z squared I am dividing with z. So z squared will become z, and k to the power of 4 I am dividing with k. So that will become k cube. And this z squared I am dividing top and down with z. So z divided by z is 1. Here all the numerators become 1. And here z squared I am dividing with z, which is z. Now you multiply here. So the numerator becomes 1 upon z squared plus numerator is 1 and it becomes k cube z cube because z squared times z is z cube. Okay, because this formula a to the power of m multiplied with a to the power of n is equal to a to the power of mn. Okay, so z squared and z is z cube and k cube plus k to the power of 4 times k squared. Numerator is 1. So k to the power of 4 times k squared is k to the power of 6 times z cube. So this we are writing as here like this. Okay. So this we are writing, okay, in the form of what we have to do x cube, z cube. Sorry, this is uh, z cube. Okay, y squared. Sorry, we have done here mistake. Y squared is yz and here it is z squared. Sorry, I have done the mistake. So that was z squared. Cut here. You get z here. So here it becomes z cube. Sorry. So that is z cube. Okay, because there was z squared. I by mistake I wrote z. So z squared is there. So dividing z and z squared with z, we get z here. So z times z squared is z cube. So this is 1 upon z cube plus 1 upon kz whole cube. Take power 3 out. And this 1 upon k squared z whole cube. Okay, because this power 3 will be the power of both k squared and z. So this is 1 upon z cube plus now kz value is equal to y. So here in place of kz you write y. So that is y whole cube plus in k squared z is the value of what z x. So x value is k squared z. So in place of this k squared z, you write here x. So it is x cube. So that comes to 1 upon x cube. I am writing the last term first. Then y1 upon y cube and the first term I am writing at the end. So 1 upon z cube. So that thing we are asked to prove. So it is proved. Hence it is proved. Okay. So we have proved what was asked in the question. Okay. Now we are moving to the next question. Now number third. Last question of question number 8. A manufacturing company prepares spherical ball bearings. Okay. Each of radius is 7 millimeter and mass of each ball bearing is 4 gram. The ball bearings are packed in 2 boxes. Each box can have maximum of so many centimeter cube of ball bearing. That is maximum of 2156 centimeter cube of ball bearings. We are asked A part, the find maximum number of ball bearings that each box can have and the mass of each box of ball bearing in kilogram. So first we are doing the A part, the maximum number of ball bearings that each box can hold. Okay. Now in the question we are asked, told to us here, the radius of the ball bearing. So radius of spherical ball bearing. Spherical ball bearing. Okay, what is the radius given? It is we are denoting that radius by a small letter r. It is 7 mm. Change it to centimeter. So that comes to 7. divided by 10, okay, centimeter. Now, why we are doing? Because the maximum volume of each box is given in centimeter cube. So find the volume of each ball bearing in centimeter cube. Okay. So what will be the volume of one ball bearing? So volume of one ball bearing is spherical in shape. So formula of the sphere is 4 by 3 pi r cube. Now find out its value by putting the values of each letter. So it is 4 by 3, pi value is 22 by 7 times r cube, which is 7 upon 10 multiplied with 7 upon 10 multiplied with 7 upon 10. So many centimeter cube is the volume of one ball bearing. Cut 7 from the top and down. And what we do, there is no other, don't divide any other number. So it is 4 times 22 times 7 times 7. Keep it like that. Don't multiply. We will multiply afterwards. 3 times 10 times 10 times 10. Okay. So many centimeter cube is the volume of one ball bearing. So the number of ball bearings, therefore, number of ball bearings. Okay. Now the number of ball bearings, it is asked the maximum number of ball bearings. So the number of, so the maximum number of, so right here, maximum number of ball bearings that each box can hold. So maximum number of ball bearings that each box can hold. Box can hold. So what will be the formula? You have to divide the volume of the box by the volume of one ball bearing. Volume of box divided by the volume of one ball bearing. Volume of one ball bearing. You will get the maximum number of ball bearings that the box can hold. So what is the volume of the here box is given? Okay, can have a maximum so much 200 2156. 2156. This is the maximum capacity of the box which can so many centimeter cube of ball bearing the box can hold. You divide with the volume of 1. Okay, so when we divide, the numerators will remain in the denominator. 4 22 and 7 times 7, and the denominator of this will move in the numerator. 3 times 10 times 10 times 10. So many ball bearings can a box will hold. So divide 2156 by 7. So 7 divided by 7 is 1. And this number divided by 7 is 308. Again divide 308 by 7. So 7 divided by 7 is 1. 7 times 4 is 28. Carry 2. Again 4. So divide 22 with 22, 1, and 44 with 22. It is 2. Divide 2 and 4 with 2. Here it is 2. Divide 10 and 2 with 2. So here we get 1. Here we get 5. Now 3 times 5 is 15. And 15 times 10 times 10 is 1500. So that is the maximum number of ball bearings that can be put in a one box. Now B part. Mass of each box of ball bearing in kilogram we are asked. Okay. Now the mass of one ball bearing. Now B part. So mass of one ball bearing. So mass of one ball bearing is how much? So in the question we are told, okay, that a a manufacturing company prepares a spherical ball, and mass of each ball is 4 gram. Okay, So mass of mass of each box of ball bearing. So each box is 4 gram. So what will be the mass of ball bearings? It is given to us. It is 4 gram. Okay, change it into kilogram, because in the question it is asked, give the answer in kilogram. So 4 grams we are changing into kilogram. It will be 4 divided by 1000. It is the mass of one ball bearing. And how many ball bearings it is one box can hold is 1500. So what is asked in the B part? Okay, mass of each box of ball bearing. So therefore, mass of each box. So each box of ball bearing will be how much? It is the mass of one ball bearing multiplied with the number of ball bearings which a box can hold. So the mass of one ball bearing is 4 divided by 1000, and 1500 so many ball bearings are hold. So you divide it. So 2020 we have cut, 15 divided by 2. Okay, 5 is 3. And 10 divided by it is 2, 5. So now you divide this. Here we get 2. So 2 times 3 is 6. So the mass of each box of ball bearing is 6 kilogram. Okay, so many kilogram. Okay, we write it properly. Okay, 1 second. So I am writing it. Okay, in kilogram the answer is asked. So the mass of each box of ball bearing is 6 kg. So it is the answer. So I hope you have must have understood. Now the question number 9. The table given below shows the runs scored by a cricket team during the overs of a match. So these are the runs scored, okay, during the overs. 20 to 30, 37 runs. 30 to 40, 45 runs. 40 to 50, 40 runs. And 50 to 60, 60 runs. 60 to 70, 51 runs. 70 to 80, 35 runs. Use the graph sheet. Here we will be using drawing this graph, okay, here in the plain surface, white surface. But in the exam, you will be provided a graph paper. In the graph paper, it is more convenient for drawing the graph. So in the question, it is saying, take 2 centimeter equal to 10 overs on one axis. Any suitable axis, 10 over will be represented by 2 centimeter scale, and 2 centimeter will be representing 10 runs along the other suitable axis. So, along the x-axis, we will be denoting overs, and along the y-axis, this runs scored we will be denoting along the y-axis, and overs we will be denoting along the x-axis, and 2 centimeters for each 10 runs, 10 overs, and 2 centimeter for each 10 runs. You have to use the scale. So here you please draw what is asked. Draw a histogram representing the above distribution. We have to draw a histogram. Okay, so we will be drawing a histogram. Now A part. So first you draw a horizontal axis. Call it x-axis. Okay, x-axis. Right? Here is the origin. And through the origin, you draw a vertical axis. That is the y-axis. Okay, here is the y-axis. Okay, so this is the y-axis. Okay, so mark here. Each take 2 centimeters. You maximum runs we want. How, what is the maximum number of runs? Is 60. So we have to draw up to the 60 minimum number of runs. So along the y-axis, okay, along the y-axis, we are denoting the what? We are denoting the runs, okay, scored. So here we are denoting runs scored, okay, and along the x-axis we are denoting the overs, okay, here overs along the x-axis. So along the x-axis we are denoting overs, okay. Now how many overs are there? Okay, up to 80, okay, 80, up to 80 overs are there. So here it is 2 centimeter. Between each mark, you will take 2 centimeter gap. So here between 0 and 10, you take 2 centimeter gap. Again from 10 to 20, 2 centimeter gap. Then between every 10 units, 10 to 20, 2 centimeter, 10 to 30, 2 centimeters, and so on. So these 2 centimeters, you will take the gap, okay, and we can easily measure on the graph paper, okay, like so on. Up to 80 runs you make here mark, up to 80 runs, okay, and between every two mark, between 0 to 10, 2 centimeter, 10 to 20, 2 centimeter, 30 to 42 centimeter, 40 to 52 centimeter, 50 to 60 to 72 centimeter, 70 to 82 centimeter gap you have to take. And for 10 runs, we are told 2 centimeter, oh sorry, 10 runs 2 centimeter. Maximum number of runs are 60. So you have to plot up to 60 at least. So take 2 centimeter gap. Here you write 10 runs. Again 2 centimeter, 20 runs. Again 2 centimeter, 30 runs. Again 2 centimeter, 40 runs. Again 2 centimeter, 50 runs. Again 2 centimeter, 60 runs. So at this we have to draw up to 60. Now here it is told to us from 20 to 30, 37 runs are made. Okay, so from 20 to 30 overs, 37 runs are made. So the gap between 20, 30, 40, 30 and 40, this gap 30 and 40, divide it into 10 equal divisions. You may see in the graph paper 10 small squares. So the seventh square mark you take, that will be representing 37. The seventh square mark. Okay, so it is told to us from 20 to 30, it is 37 runs. So you draw a bar from 20 to 30. Okay, a bar of height 37. So up to this side. Okay, up to this side, and that bar will be going rising from 20 and dropping at 30, and the height of the bar will be 37, which we can easily, okay, see from the graph paper. Okay, the seventh division, if there are 10 divisions, between there are 10 small squares between 30 and 40. So you have to write the scale also. So write the scale here on the top. So along the x-axis, what is the scale we are using? 2 centimeter is representing 10 overs. Okay, and along the y-axis, okay, we are denoting their runs. So 2 centimeter is representing 10 runs. You have to write there, okay, scale. Okay, now see here. Now next, first you shade it. Okay, shade this bar. Okay, shade this bar. So you have to shade the bar. Okay, next, what is here from 30 to 40? The number of runs scored is 45. Okay, 30 to 40, it is 45. Okay, 30 to 40, it is 45. So the fifth division, if there are 10 smaller squares between 40 and 50. The fifth smaller square will be representing 45 runs. So we will draw a bar, okay, rising from 30, okay, and dropping at 40, and the height of that bar will be how much? It will be up to 45. Okay, this up to here, the up to the mark 45. Okay, and you shade it. So this is, okay, required shading. Okay, shaded this bar. Bar is going from 30, dropping at 40. Height is 45. Next is here. What is here? 40 to 50. The number of runs are 40. So you make a bar of height 40. Okay, draw up to 40. Okay, this up to 40, rising from 40 mark on the x-axis and dropping at 50 mark on the x-axis. So of this height, the bar will be, okay, rising up from 40, dropping at 50, and height is 40. Okay, so you shade this bar. So all the bars will be touching one another in the histogram. Next is here. 50 to 60 is 60. 50 to 60 is 60. So draw a bar up to this height, up to the 60 mark on the x-axis. So where the horizontal line, okay, passing through 60 up to this mark, we will be drawing a bar rising from 50 and dropping at 60 of this height. Okay, so you make a bar of this height going up from 50, dropping at 60. So this is all the bars will be touching one another. Okay, so this is the bar going from 50 coming to 60. Okay, of height 60. So this is the number of runs scored is 60 here shown. Next, 60 to 70 is the 51 runs. So you have to show 51 runs from 60 to 70. So the first mark, if there are 10 mark divisions from 50 to 60, the first division over above 50, that will be representing 51. So you will be making a one bar of this height going, okay, from 60 and dropping up to 70. Okay, of this height you will make a bar. So this is representing 51 runs. Okay, so shade this bar. Okay, so this is showing the 60 to 70 is 51 runs. Now next, first you shade this bar, and last is here. 70 to 80 is 35 runs. So you have to draw a bar rising from 70, dropping up to 80. And how many runs? It is 35. So you will draw up to the 35 mark. That is the fifth division over 30. So if there are 10 divisions, 10 small squares between 30 and 40, the fifth division over 30, that will be 35. Okay, so you make a bar up to this height, up to this, okay, height. We are making a line, okay, through 35 horizontal line. Okay, up to this height. Okay, that is 35. On in the graph paper, we can easily locate 35, and all these bars has to be made by using pencil and the scale, not by freehand. Here I am drawing by freehand, but in the graph paper, in the examination hall, you will be making these bars all with the scale and pencil. So that is the histogram made. So A part is done. Now B part, estimate the modal runs scored. So how we show the modal run? So the the highest bar you take. Okay, so you mark the, okay, the edge, corner edges, corner points, where it is meeting with the previous bar as well as the succeeding bar. So we call these points, suppose A, B, C, and D. Now, what you will do? You will use a scale, not the pre-hand. You will join the opposite points A and C. You will join with the scale and pencil, not pre-hand. Okay, join A and C, opposite points, with scale and pencil, and join B and D also with scale and pencil, where these two lines are meeting. Okay, here they are meeting. Suppose we call it M. From that meeting point, the line joining AC and BD, where it is meeting, from that meeting point, you will make a one line perpendicular to the x-axis by using a scale and pencil. So, where this meet, this vertical line, where it meets the x-axis, that is the modal score. Okay, so it is what? 57 approx. Okay, so it is 57. So the modal, okay, runs score is 57 runs. So that is the answer. So B part. So modal runs. So the modal runs is how much? It is 57. Modal runs scored is here. You read this mark. Here it is 57. Thus, approximately you may see in the graph paper very clearly. But here we are doing, okay, rough sketch. So I am just guessing it. It may be approximately 57 runs. So that is the answer of B part. Now we are moving to the second part of this question number 9. Okay, what is the question saying? An arithmetic progression. So this is a AP series. Okay, has 3 as the first term. So the first term of the AP is told to us, it is 3. The sum of the first 8 terms is twice, that means double the sum of the first 5 terms. So you are asked, find the common difference of the AP. So see here how we do this sum. So the given AP, this is the AP told to us. So let the first term we denote by the letter small a. Its value is given in the question. It is 3. We are asked to find the common difference. So let common difference, in short, we are writing CD. We are taking its value as D. Okay. So the sum of the first 8 terms. Now we know the sum of n terms formula. Sum of n terms of an AP formula, we denote the sum of n terms by Sn. Its formula is n divided by 2 times 2a. A is the first term, plus n minus 1. N denotes the number of the term, multiplied with d. D denotes the common difference. So here, the what will be the sum of the first 8 terms? So therefore, sum of first 8 terms, first 8 terms, that is denoted by S8. So that is the formula. In the place of n, you write 8. 8 divided by 2 times 2a. A value is 3. So 2 times 3 plus n is here 8. Uh, First 8 terms, 8 minus 1 times d. D value we don't know. So just I am writing here d. So divide here. 4, 8 I am dividing with 2. Here you get 4. So it is 4 times, simplify this. So 2 times 3 is 6 plus 8 minus 1 is 7. 7 times d is 70. So that is the sum of the 8 terms in the form of d. Okay, now the sum of the first 5 terms, you find out the value. So therefore, the sum of first 5 terms. So what we denote it as S5. So the formula is, you write 5 divided by 2. Here n is 5. Okay, in the place of n we will write 5. Okay, n denotes the number of terms. Okay, multiplied with 2a. A value is 3. So 2 times 3 plus here n minus 1. So n is here 5. So in the place of n you write 5. Okay, minus 1 times d. So on simplifying, what we get? We get 5 upon 2 times 2 times 3 is 6 plus 5 minus 1 is 4. 4d. Now you take 2 common out from that. So 5 upon 2 and 2 I am taking from the 6 and 4d inside the bracket. 2 I have taken common out. So divide these both the terms by 2. So 6 divided by 2 is 3 and plus 4d divided by 2 is 2d. So you cut 2 and 2 from the top and down. So it is 5 times 3 plus 2d. So that is the value of the sum of the 5 terms in the form of d. Now in the question we are told the sum of the first 8 terms is twice double. So now you make the equation of the sum of the first 5 terms. So the sum of the first 8 terms is twice the sum of the first 5 terms. So you multiply the sum of the first 5 terms with 2 and equate it with the sum of the first 8 terms. So the sum of the first 8 terms value is 4 times 6 plus 7d. That is equals to 2 times the sum of the first 5 terms. So 2 times 5 times 3 plus 2d. Now there is only one variable here, d, unknown. There is only one unknown in this equation, d. Now that value we can obtain by solving this equation. So 4 times 6, now multiply, okay, this 4 times 6 is 24 plus multiply the terms inside the bracket with 4 on the left side. So 4 times 7 is 28d is equals to 2 times 5 is 10 and 10 you multiply with both the terms inside the second bracket. So 10 times 3 is 30 plus 10 times 2 is 20, 20d. Now bring the d terms to the left. So that is, we are moving the d terms to the left and the constant terms to the right. Okay. Now what you will do, you bring the d terms to the left of the equal sign. So 28d minus 20d. Value is equals to 30. 24 I am moving to the right. So minus 24. Now 28d minus 20d is 8d. Value is 30 minus 24 is 6. So the d value is 6 upon 8, which is 3 by 4. So that is the common difference. Okay. So that is the answer. Okay. Common difference. Okay. Now we are moving to the last question of question number 9. Okay, and this is the last question of today's class. The question number 10, the last question we will be doing in the next class. So what is the question saying? The roots of the equation, there is a one equation given, q minus r times x squared plus r minus p times x plus p minus q is equals to 0. This is a quadratic equation. The highest power of x is 2. So this is a quadratic equation. Okay, so the x squared coefficient is q minus r and x coefficient is r minus p and the term pre from x is p minus q. Okay, that is the quadratic equation. So roots of this equation are told to us are equal. So roots are both equal. Okay, so we have to prove that if the roots are equal, then you have to prove 2 times q value will be equal to p plus r. Okay, that is p, q and r are in ap. So if the sum of the middle term is q is in the middle term, here p, q, r are in ap, that is q is in the middle term. So if the three terms are in ap, then there is a relation between the three terms. The 2 times the middle term value is equal to the sum of the two, okay, first term and the third term. Okay, so that we have to prove. Okay, now see here. Now the given equation. First, let us write the given equation. So given equation is here q minus r times x squared plus r minus p times x plus p minus q value is equals to 0. Now in the question we are told the roots are equal. Now because the roots are equal, now roots are equal. So when are the roots equal? So the roots are equal when the discriminant value is 0. Okay, because we know the a quadratic equation is denoted like this. Roots are equal. Okay, a quadratic equation. Okay, general form we denote a quadratic equation like this: ax squared plus bx plus c is equals to 0. Okay, and the roots are what? Roots are in a quadratic equation minus b plus minus square root of b squared minus 4ac whole divided by 2a. Siddharacharya's formula. So when the roots are both equal, so this expression which is within the root sign, which we call the discriminant, its value should be 0. Here a denotes the coefficient of x squared, b denotes the coefficient of x, and c denotes the term pre from x, that is the constant term. Okay, now because the roots are equal, therefore the discriminant value, so therefore the discriminant value, okay, which we denote by capital D, which is equal to 4b squared minus 4ac. Discriminant value is always equal to 0 when the roots are equal. Okay, now what is b? B is the coefficient of x. So that is this one, this r minus p. Therefore, you put here r minus p whole squared. Okay, minus 4ac minus 4 times a. A is what? The x squared coefficient, which is q minus r. Okay, q minus r times c. C is what? C is the constant term, that is pre from x. Values should be equal to 0. Now you simplify this, you will come to this result. 2q value will be equal to p plus r. You will come to that result. Okay, now I am simplifying it. So square r minus p whole square. Okay, r minus p whole square, you simplify it using a minus b whole square formula. So a squared r squared minus 2ab, that is 2 times pr plus b squared, that is plus minus p whole squared is p squared. Okay, right here minus 4. Now multiply these expressions. Okay, q minus r with p minus q. So q multiplied with p is pq. Q multiplied with q minus q, that is minus q square, minus r multiplied with p is minus pr, and minus r multiplied with minus q, that is plus qr. Value is equals to 0. Now simplify it. So what we are getting? R squared minus 2pr plus p squared minus 4pq. Multiply all the terms within the bracket with minus 4. So minus 4 times pq is minus 4pq. Minus 4 times minus q square. Minus multiplied with minus is plus 4q square. Minus 4 times minus pr. That is 4pr. Minus 4 times qr is minus 4 QR. Its value is equals to 0. Okay, now you further simplify it. Okay, so here we are writing P squared plus 4Q squared. Okay, plus 4Q squared plus R squared. Okay, and here minus 2PR. Okay, and plus 4PR. These are the like terms. Minus because their variables are same, PR and PR. So minus 2PR plus 4PR is plus 2PR. And minus 4 PQ. Here, this and these are left. So minus 4 PQ and minus 4 QR. Value is equals to 0. Now see here, we know the formula of the square of the here like three terms. A, okay, plus B, okay, plus C. Whole square formula is what? Here, okay, here you notice here. In this, here the product of P and Q are negative. Okay, and the product of Q and R is negative, and the product of PR is positive. So P and R should be of the same sign. Okay, and here P and R should be of the same sign. Okay, and Q will be of the different sign. Okay, so the first two here, these two, okay, will be of the same sign. Okay, now in place of suppose I write here. Okay, now you please pay attention. Okay, now you please pay attention. Here, uh, here P, okay, and P and R is of the same sign. Okay, so uh, here P squared, square root is P, and here R square root is R. Okay, so R, and 4Q square root is plus, okay, plus PR plus R, and middle term Q you will put negative, okay, opposite side, because P and R should be of the same side. Then only you will get the product as plus, and the other here other two terms you will have here what, the here the Q will be of the opposite side. Okay, then you will get, and here 2Q. Okay, whole square. So what is the formula of squaring it? So that is P squared minus 2Q squared is 4Q squared plus R squared is R squared, and multiply these two terms. And you first you write 2 and multiply here pairwise. P times minus Q is minus 2PQ. Okay, and Q times minus R minus Q times plus R, that is minus 2QR, and plus R times P is plus PR. So that is the formula of the square, okay, of three terms P minus 2Q plus R. So when we expand it, P squared plus 4Q, okay, here it is 4Q squared, sorry, okay, uh, 4Q squared, 2 square is 4, Q square is Q square, so 4Q square plus R square, okay, and you multiply here with 2, so it is 4 times PQ, okay, 4 times PQ, and minus 4 times QR, and plus 2PR. So that is the thing we are having here. P squared, okay, plus 4Q squared plus R squared plus 2PR minus 4PQ and minus 4QR. So this is equal to P minus 2Q plus R whole square. So that is equals to 0. So when the square of a some expression value is equals to 0, so the expression free from the square will be also equal to 0. So we are getting here P plus R, bring minus 2 to Q to the other side. So 2q value is equals to p plus r. Right, 2q on the left and p plus r on the right. So it was asked to prove, hence we have proved it. Okay, so that is proved. So I hope that you must have understood, okay, the here everything. So let's now end of the class. Okay, have a very nice day. Bye. Okay.